Hello everyone. In today's session, we'll learn two concepts, correlation and regression. First, I'll define what is correlation. Covariation of two independent magnitudes is known as correlation. That means if two magnitudes x and y are there and you want to know how they are varying with each other or how they are related to each other, that's given by correlation. There are two kinds of correlation. One is positive correlation and one more is negative correlation. If two variables x and y are related in such a way that increase or decrease in one of them corresponds to increase or decrease in the other, then the two variables are said to be positively correlated. That means if x and y are two variables and they're moving in the same direction, then they are said to be positively correlated. That is, increase in x will yield increase in y, or decrease in x will change y also in the same direction. Then these two variables are said to be positively correlated. To give an example, height and weight of a boy are positively correlated. That is, as and when the height of the boy increases, weight also increase. So they are moving in the same direction. That's the reason this is an example for positive correlation. And the second one is negative correlation. If increase or decrease in one of the variable corresponds to increase or decrease in the other, then the variables are negatively correlated. That means if x is increased, y decreases. Vice versa, if x is decreased, y increases. Then the two variables are said to be negatively correlated. To give an example for negative correlation, altitude from Earth's surface and temperature. As and when the altitude from Earth's surface increases, obviously the temperature decreases. That means they are moving in the opposite direction. So this is an example for negative correlation. So given any two variables x and y and you want to know how they are correlated, whether they are positively correlated or negatively correlated, you can measure that by a numerical measure of correlation, which is known as Pearson's correlation coefficient. And that's denoted by small letter r. And you can find that value by using any of the three formula which are mentioned here. The first one, r is equal to summation capital xy by square root of summation x square into square root of summation y square. All the letters here are capital X and capital Y, where capital X is small x minus x bar and capital Y is y minus y bar, where x bar and y bar represent mean of x and y. They are the average of given x values and y values. That's how you can find r value using the first formula. The second one, the alternative formula, the second alternative formula is r is equal to summation of x minus x bar into y minus y bar whole divided by n sigma x into sigma y, where x bar and y bar are mean of x and y, n represents the number of values given, sigma x and sigma y represents standard deviation of x and y. Sigma x and sigma y you can find out by using these two formula. Sigma x square is equal to summation x square by n minus x bar the whole square. And sigma y square is equal to summation y square by n minus y bar the whole square. And coming to the third alternate formula, r is equal to sigma x square plus sigma y square minus sigma x minus y square whole divided by 2 sigma x sigma y, where sigma represents standard deviation. So this is the alternative formula for the correlation coefficient. So any of the three you can use and find out the value of r depending on the given data. And one thing you should remember is r value should always lie between -1 and +1. If it exceeds this, it means you've gone wrong in the solution. So please do recheck. Whenever you solve for r, you have to see to that r value always lies between -1 and +1. That's a range for r. Now coming to the second concept, regression. It is an estimation of one independent variable in terms of the other. That means if x and y are two variables and x and y values are given and you want to know the relation between x and y, it is given by regression. There are two kinds of regression lines. The first one is regression line of y on x and the second one is regression line of x on y. Regression line of y on x will give you y relation in terms of x, and regression line of x on y will give you the line x in terms of y. So to find these two lines when given x and y values, we make use of this equation. The first one, when you want to find out y as a function of x, it's called regression line of y on x and is given by y minus y bar equals r into sigma y by sigma x into x minus x bar, where x bar and y bar represent mean, r represents correlation coefficient, and I have just mentioned how to find that. Sigma x and sigma y represent standard deviation of x and y. And the second line is given by regression line of x on y is given by x minus x bar equals r into sigma x by sigma y into y minus y bar. So this is how you're going to find the two lines when x and y values are given. Here, this coefficient r into sigma x by sigma y is denoted by bxy and is called regression coefficient. And this one, r into sigma y by sigma x, is denoted by byx and is again called regression coefficient of x. And these two coefficients are helpful to find out r when two lines are given, and that I've mentioned in this note. The first note, r is equal to square root of coefficient of x into coefficient of y. So given two lines, just find out coefficient of x and coefficient of y, substitute, you will get the value of r. And the second note, if r is equal to 0, then the two lines are mutually perpendicular. If two lines are given and you want to know whether they are perpendicular to each other, then you can just find out r value using this formula. And if at all it turns out to be 0, then you can conclude the two lines are mutually perpendicular. And the third note, if r equals plus or minus 1, then the two lines coincide. If two lines are given and you want to check whether they are coinciding or whether they are meeting, you just find out the value of r. If r turns out to be plus 1 or r turns out to be minus 1, then you can conclude the two lines coincide. And the fourth one, there's an alternative formula to what I mentioned just now, regression lines. Regression lines can be found by using these two equations, or else it can be found by the equation which is mentioned in the fourth note. This one is simpler compared to the one which is previously mentioned. Capital Y is equal to summation xy by summation x square into x. This will give regression line of y on x. And if you want to find x on y, it's given by capital X is equal to summation xy by summation y square into y, where all the letters mentioned here are capital X and capital Y, where capital X is small x minus x bar and capital Y is y minus y bar. Using this equation, it's simpler to solve and find out the regression lines. Hope this video was helpful. Thank you.